All right, so this is pretty much where we left off last time. We had a system of equations, right? So, and we saw that in this case, with two variables, right? Those define lines, and these lines happen to intersect each other at the point x = 1/2 and the point y = 3/2. We also saw that when we combined two equations together, right, we talked about how I can multiply any equation by any number and we get the same number of points. And so just as an example, I said, okay, well, for instance, we could multiply this guy by 2, and then we could take these two things, add them together to get a new line. And that new line happens to go through the same point as those two lines went through. Now, before we move on, I just want to mention how, because this whole, everything we're trying to do is to develop a method for solving these things. And another thing we want to notice is that if I were to just take these two equations, combine them together and get one new line, and then I were to like forget about both of those equations, well, then I'd be in a really bad place because I would just have this one new line and that's it. We would have infinitely many points, which make this true, right? Like for instance, the point 1, 4 should work and all the infinitely many points that lie on this line. So if we combined equations, got a new equation, and then forgot everything else that we originally had, well, we'd be worse off because we would just have one line. Good luck, right? There's infinitely many solutions to one line. So in principle, though, what we could do is we combine these two, we get a new line. Then what we could do is we could forget about one of the original lines. We could either forget about this one and we could see like, yeah, we have two new lines that cross, or we have two lines that cross at one point, we're good. We could forget about this one and say, okay, we have two lines that cross at one point, we're good. If we were so inclined, we could keep all three lines, but now we've just made our problem even harder, right? Like now we have three equations to worry about. So in principle, what we're going to be doing is we're going to be combining equations, getting a new equation out of it, and then forgetting about one of our old equations. But ultimately, we want to keep the same number of equations with us the whole way along. And this is because of a principle here that is true, not just for nice linear equations, but for anything that you do in math, physics, or chemistry. If you have two unknowns, you need two equations to solve for them. So like in this case, we have two unknowns. We don't know what x is and we don't know what y is. And in order to find a specific x and a specific y, we need two equations. Geometrically, right, we're saying that two lines are needed to describe one point. If you have three unknowns, x, y, and z, guess how many equations you need to specify three unknowns?
Three.
Okay. If you have four unknowns, you need four equations. If you have five unknowns, you need five equations, and so on and so on. However many unknowns you have, that's exactly how many equations you need in order to specify it exactly. And it has this nice geometric representation here with lines, because yeah, you could kind of see that. If we forgot about our original two lines and just had this new line, it's like, well, all we have is just one line. We'd have infinitely many points. That doesn't help us. Two lines, if they intersect at all, will intersect at only one point. And so that's kind of that's another principle that we're going to be using. Okay, so that's just kind of review of what we've done thus far. Now we're going to get to a method. But first, I'm going to do the method in the way that we're not actually going to do it, so that when I show you the method, you could go, oh, that is a little bit nicer. Okay, so first, what I'm going to do is just take this system of equations, these two original equations that I wrote up, and I am going to employ the method that I'm going to, so I'm going to do it a couple of times before I give you like write up the actual rules up on the board. And so just bear with me on that, okay? So first off, what I'm going to do is say, well, and we did this last time where it's like, I want to get rid of this guy right here because I'd like to just have, if I could just get y by itself, then I'll have some equation that says y equals something. And so what I'm going to do is think, okay, this is like we did before. We have 3x plus y equals 3. And I know that if I'm going to add this to another equation, and I want this to come out to 0, there's only one way to do that. This has to be a negative 3x right there if I want that to come out to 0, which is what I want to do. I want to get rid of one of the variables. I'm going to start by getting rid of x. And you might be looking at that and thinking, why don't we start with y? That one's really easy. Like you just add them together and the y's go away. Trust me, just trust me on this. So I'm going to start with x and get rid of the x that's on the bottom by saying, well, the only way to add something to 3x and get rid of it is with a minus 3x. Then I'm going to look up here and say, what number do I need to multiply everybody by to give me a minus 3x there? Oh, well, luckily, I had a 1 in front of that x. I only have one x. So it's really easy to figure what number I need to multiply 1 by to give me a negative 3. And that happens to be negative 3. It's almost as if I set it up that way. So I multiply the top through by negative 3. I get negative 3x, positive 3y equals negative 3 times negative 1 is a positive 3. I add the equations together and I get a new equation. I get 0x's plus 4y's equals 6. And so in other words, 4y equals 6, like I said, we have now just solved for y. We have y by itself, although it's not exactly in the way I want it. I want the y, it's not exactly by himself. He doesn't have another x there. But that y, we could get y by himself very easily by taking this, dividing both sides by 4. And that gives me a y equals 6/4 reduces to 3/2. And what do you know? That is indeed the output that we're looking for. It's the y value where those two lines cross. So that looks good. Now, what did I just do? I combined two equations and got a new equation. I don't want to forget about the other equations, right? Because now I just have a line. In order to find that second point, I still need another line to go along. So what I'm going to do is say, I'm just going to rewrite this system. And now what I'm going to do is replace, I don't know, I could use either one, but I'm going to choose to replace the second equation with my new equation. That gives me x minus y equals minus 1. Now I have a new line, which is y equals 3/2. Now I'm going to say to myself, well, if I could get x by himself, then I'll know what x is. And I could say, well, and in this case, it's nice and easy. I don't have to do that thing earlier where I said, well, I have to multiply this by negative 3 in order to make those cancel. It happens to be, and this will not always be the case, but it happens to be that when I just take this guy and add him to that one, the y's disappear. So I'm going to go ahead and do that. I'm going to add those together. And I get, okay, x plus 0 is a big fat x, minus y plus positive y gives me a 0, which is what I'm looking for. And that equals 3 halves minus 1. Okay, 3 halves minus 1 can be written as 2 halves. 3 halves minus 2 halves is 1 half. And so I get 1 half. Lo and behold, now if I were to write this out as another system, I would have this right here. I would have x plus 0 equals 1 half. 0 plus y equals 3 halves. And that was my goal, right? It was to find the value of x that makes that true, that makes both of them true, along with the same value of y that makes both of them true. I have done what I finished. Okay. So here's the thing. I'm lazy. I'm lazy, and so are most mathematicians. And I notice that every time I wrote this stuff down, because of the way that I did it, I didn't really need to write all the x's and the y's and the equals because, well, I've kept them all in the same column, right? Like my x's are always right here, no matter what. My y's are always right here, no matter what. What on the other side of the equation, there's always an equals and there's always a single number for every single time. So what I'm going to do is just say, you know what? Instead of wasting all my time trying to writing down the x's and the y's and the z, I know that whatever shows up first has an x variable. I know that whatever comes up next is a y, and then whatever last is my equals stuff. So now, this is purely formal here. I'm just kind of saying, just hear me out. Instead of doing that, what I could do is just say, well, how many x's do I have? I guess I have 1x. So I'm just going to say, instead of writing x minus y, I could write 1 minus 1. And I'll know that that means, okay, you have 1x there, a minus y, that's a minus 1. And then finally, equals what? Well, a minus 1.
Oh.
I'm just being lazy, right? I'm just kind of saying, well, I'd rather not have to write x, y, and equals every single time I do this, because look at how much time I wasted. Every single time I did this, I wrote an x, y equals, x, y equals. I had 6 symbols here that I didn't need to write. 6 symbols here I didn't need to write. I kind of did some stuff here. Again, a bunch of symbols that I did not need to write down. I could just say, I know that this means that right there. Similarly, I could say I have 3 x's and 1 y and 1 3. I could say there's 3 x's, 1 y, and 1 3. Now, similarly, if I had something like this, 2 minus 5, 2, 7, 11, and 1 half, I would know that that's, okay, this is the same kind of thing. This is just this means this is my x's place. So this means I have 2 x's. This means I have minus 5 y's. The last one is equals whatever. So that equals 2. This is 7 x's. This must be plus 11 y's. And that equals 1 half. And so this is just a lazy way of writing this, right? Now, I'm going to go ahead and do this and say, well, what if we had 3 equations and 3 unknowns? Just give me a second here, right? Like if I had 3 equations with 3 unknowns, I could waste my time going, I don't know, 11x plus 2y minus 3z equals 1, and x minus y plus z equals 2, and, oh, I don't know, 2x plus 3y minus 4z equals, how about 3? Or I could say, man, you wrote 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 symbols that you really didn't need to write down. I could just say, okay, well, how about 11, 2, minus 3, 1. 1, minus 1, 1, 2. 2, 3, minus 4, 3. And this will just we'll just agree from now on that when we write this, what we really mean is this system right here. So now there's one trick. It's not a trick. It's just that there's something you have to be careful of, is that if one of these happens to be a 0, and what your book will do is it'll give you a system of equations like this. It'll say x plus z equals 2, y minus z equals 1, and how about x plus 2z? Oh no, we want a x and a z and a y. How about x and y and x and z, x and y? There you go. How about 2x minus y equals 3? Now this is tricky because each one of these doesn't account for the other variables. We understand this is a system of a bunch of variables, or of 3 variables. And so what this really is, if we wanted to account for every variable, we have to account for that y. I could rewrite this as x plus 0y plus z equals 2. This would have to be 0 x's plus 1y minus a z equals 1. This would have to be 2 x's minus 1y plus 0 z. And so if we were given something like this, when we go to write it in, this is called an augmented matrix. This thing right here is a matrix. A matrix is an array of numbers. That's what we're going to call it from now on. It's just an array of numbers. It's a way of talking about systems of equations. And usually, by augmented, what we mean is that this last column here stands for the equals part of the equation. Usually when you see the plural of matrix is matrices. So usually when you see matrices and when you go to learn about them in depth, we don't really talk about this side. And so it's just the actual equations, or it's just the functions themselves that are in the matrix. And so when you add on the equals side, we augment the matrix. And so this is what we're going to call an augmented matrix. And that's all we need to know right now, is that it's a fancy way, or rather a lazy way, of writing a system of equations. And so this guy, if my book gave me this right here, and I wanted to write it as in matrix form, I could say, okay, first off, let's agree that that first column is x's, the second column is going to be my y's, my third column is going to be my z's. And that's the way we're going to do. They're also going to give you like P, Q, and R, A, B, and C, and stuff like that. And we'll just agree that the first letter, whatever it happens to be, in this case it's X, will be on the far left. The next one will be the next letter. The last one will be the last letter. So sometimes they will flip these around and they'll have Z and everything. But what we're going to do is say, okay, for the first one, it does have an X and there's one X. It does not have a Y, so it's a 0. It does have a Z, so there's a 1, and it's equal to 2. The next one does not have an X, and so that's a big 0. It does have a Y, it has a positive 1Y. It has a minus Z, so we have a minus 1Z, and it's equal to 1. We have 2 X's. X is the first column. It has minus 1 Y's, no Z's, and then that is equal to 3. So we can agree then that this thing is a fancy way, or I'm going to keep saying lazy way. It's a lazy way of writing this right here without writing down all the variables. We just understand that everything in here is multiplied by X, and we add that to whatever this is multiplied by Y. Add that to whatever this is multiplied by Z. And then right here, we have an imaginary equal sign, and then you have whatever your number is over there. Does that make sense?
Yes.
Okay. So let's just check your understanding here. Let's say let's say that my book tried to trick me and wrote something like this. figure this out. So let's just do the first one. What goes in the first place here for this? What should be the first number? Say again.
-1.
-1, right? Because we understand just by looking at this, it's like, what are my three variables? I got X, Y, and Z. We're going to call X the first one. And so in that first equation, X has a negative in front of it. That's the same thing as a -1. Okay, what comes next in the next column here?
0.
0, because there are no Y's. What about the third column?
+1.
+1. And then finally,
2.
2. There we go. What about the next row? What is the first thing in the next row?
0.
A 0. And then a what?
+1.
+1. Then
+1.
+1. Finally,
1.
1. What about the last one?
+1.
Uh-huh.
+1.
Uh-huh.
0.
Uh-huh.
3.
Good. Excellent. Right? Don't be tripped up because they're going to do this to you. They are going to do this to you. And you have to know, oh, wait a minute. Just because that's the second thing doesn't mean it's not the first variable. They've just rearranged it. And so if I gave you this and said to solve this system, this is going to be our first step. I will write these down at some point, but that's your first step, is to take your given system and write it in augmented matrix form. Why? Because we're lazy and it's going to be much easier for us this way. Okay, now before we, can I go ahead and erase this stuff right here?
Yes.
Okay, so now let's think about this. My goal in all of this, my goal is to get down to here. I want X by itself. I want X equals a number, and I want Y equals a number. My goal is to turn this thing into something that looks, well, like this. And if I were to write this in matrix form, what I want is a 1 in the first, because that's the X place. There's a 0 here in the Y place. I want a 0 for the second equation in the X place and a 1 for the Y place. And then it should equal whatever it equals. It should be, in this case, it should be 1/2 and 3/2. This is my goal, right? Now, if I started with I'm going to call it a 3x3 or a 2x2. And what I'm talking about is the number of equations. And that's you can see that's the vertical, right? So we're talking about the number of equations by the number of variables. And so you're going to be like, well, wait, shouldn't this be a 2x3? No, because this is a weird augmented matrix. And what we're talking about are the number of equations and the number of variables. And I said, we always need the same number of equations as we do variables. So this is a 2x2. And so this is the goal. We want to turn this into this. Similarly, if we had a 3x3, and I'm just going to make stuff up here and say, let's say we had this, and oh, I don't know, -2 and 5 and 4 and 1. If we had something like this, my goal, and now I know that that represents 2x plus 3y plus 5z equals a number. 7x plus 11, blah, 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 blah. That's just 3 equations. My goal is to get, right, x equals something, y equals something, z equals something. And so in matrix form, what that would look like is I want an x plus a 0 plus a 0. And a 0 plus a y plus a 0, and a 0 plus a 0 plus a z. And so in matrix form, my goal is to get this guy, where we have a 1, 0, 0, 0, 1, 0, 0, 0, 1, and then whatever these numbers are, we'll just call them, say, A, B, and C. That would be my goal, because then, right, if you could turn this guy into this guy, then you'll know, wait a minute, that was just a fancy way of writing an equation. And so what this is telling me is that x is equal to A. This is telling me that Y is equal to B. This tells me that Z is equal to C. In the same way that this is the goal for a 2x2, right? You're trying to get X by itself and you're trying to get Y by itself. So is that making sense thus far?
Yes.
Okay, one second. So how do we go about doing this? And you'll notice if like you read the book, after doing like 10 of these, and you read the book, you'll see like we're doing the same thing. The way that we're going to do it is a bit more principled. Like I said, we're looking for an algorithm, a method for going through and doing this that's going to work every single time. But we're going to end up doing the same thing as the book, basically. But our way is going to be principled. But at any rate, our goal with anytime the book or I say, solve this system, what we're asking for is what is X, what is Y, what is Z? In matrix form, that's how we write them. And so let's kind of just go through and think about this. Now, another nice thing about thinking about it this way, it's like I said before, when we're going to add equations together and get new equations. And when we do that, we don't want to throw away all of our equations. In order to solve a 2x2, we need two equations. So this notation is going to help us to remember, oh, I better have two equations with me every single time. Because when you start doing stuff like this, and when you do the methods that the book says, it's easy to forget the bigger picture. And it's easy to start getting lost in this one equation that you're working on and forget like, oh yeah, that's right. I had other equations. I need to figure out which ones I'm keeping. This is going to help us to not do that. So let me just show you the way I'm going to do it. So this is our reasoning. It's like, I need to turn this thing into this thing. I notice that there's already a 1 right here. We call this a leading 1 because it's in the lead, right? It's out front. It's a leading 1. That's good. That's actually your second step. Is first step, write your system as a matrix. Step 2, get a leading 1. We will talk about how to do that in a minute. But I already have a leading 1. Well, that's nice. So that means then this is what you're going to do. But you have a leading 1. We want zeros all the way down here. If it's a 3x3, then you'll want a 0 here and a 0 here. In the case of a 2x2, you're going to want a 0 right there. And so I ask myself, what, because I know I'm about to add, and this is like the same thing I did right here. I ask myself, well, I have a positive 3 that needs to turn into a 0. What number plus positive 3 equals 0? Well, there's only one possibility, and it's a negative 3, right? Like whatever number that is, we just take it and make it negative. Like if that were a 17 over 5, I would say, well, negative 17 over 5. If it were negative 5/17, I would say, oh, it needs to be a positive 5 over 17. In this case, I know I need it to be a 3. So I'm just going to kind of do this right here. The way I like to do it is I like to write what I'm about to add to a row. I like to write it just outside of the matrix. This is not standard. This is just the way that Justin started doing it when he was in algebra 2. I don't know. It's been forever. I've always done it this way. But it helps me it helps me organize stuff. So basically what I'm doing here is I'm taking negative 3 times this top row, and I'm just going to write it right here. That way, okay, so negative 3 times a negative 1 is a positive 3. Negative 3 times a negative 1 is a positive 3. And now what I'm going to do is I know why I did that. It was to get a 0 in this place. So, and this is going to be a principle. Every time we rewrite a matrix, the first thing we're going to do is identify the row that is not changing. Every time you rewrite a matrix, you should have a row that does not change. And in this case, it's the top row. And that's going to be the way it's going to be every time you do one of these, right? You're going to have that because you will have already had a leading 1, because that's like step 2, get a leading 1. And you can see, like, that's what you need. That guy needs to stay right there, ultimately. But now we need to go about getting zeros here, and that's what I'm doing. So I'm going to say -3 plus 3 is a 0. +3 plus 1 is a 4. +3 plus 3 is a 6. Okay, we're getting close. Now it's looking a lot like what we want, at least that column. And by the way, the vertical entries are called columns, and the horizontal entries are called rows. So this first column is good. We are done with the first column. We're not going to come back to it. It's done. Now I need to, and now that I've gotten down to the bottom here, I'm going to start working my way back up.
I have a question.
Yeah.
Well, how did you get +3 for -3 times 1?
-3. I took -3 and
Uh-huh.
multiplied it by that whole row right there.
Oh, I see.
Yeah, and so that is what I did there. And because this is what I'm doing. This is why I wanted to have this written over here. Is this calculation that I'm doing to give me this new row is this calculation. I'm taking -3 times the first row, and I'm just writing it here. But I don't want to actually change that row and rewrite it that way, because I know in the end, this is the picture I want. Something like this, right? And so that's what I like to do. That's why I said I like to write it on the outside. And so that's all I'm doing. This is pretty much notation right here. This is just Justin notation. I do that to help me because you could easily, like, you could try to do this in your head and say, well, okay, -3 times the 1 plus that gives me a 0. Okay, -3 times the -1 gives me a +3 plus 1 is 4. But it's so easy to screw that up, you know? So that's just what I like to do. I'm going to take -3 times the top row. -3 gives me -3. -1, -3 gives me a +3. -3 times -1 gives me a +3. And that's the thing I'm going to add to this row. Then that, and then remember, we want to identify the equation that is not changing, the equation that's coming along, and I wrote that guy first. Then I'm going to do my add these rows together to get a new row. In other words, to get a new equation. But like I said at the beginning, right? We don't want to throw away all of our old work because we need, ultimately, every time we need to have 2 lines in order to define a point. And so I just copied him down before I did any other calculations. Then I said, okay, what would happen if I took -3, multiplied it by the first row, and added it to the second row? Well, we would have this. And so that's what I did. But in this case, I never needed to write down all those variables and all those equals because I understand that we're doing the same thing here. Ready to move?
Mm-hmm.
Okay. Now we have this in what is called upper triangular form. Don't worry about it. It's just, it's like now this looks a lot like this, which is what I want. The only problem is I want that to be a 1. So I need to turn it into a 1. So that's going to be my next step. I'm going to say, okay, how do I turn that number into a 1? I don't need to use my brain for this. Whatever number it is, if it's a -7, divide by -7. If it's a +105, divide by +105. If it's 7/3, divide by 7/3, but that's the same thing as multiplying by the reciprocal. It's just that'll help you out, right? But I'm just asking myself, I need to get rid of that guy, and I'm going to multiply this row across, or I can divide the row across. I need to divide this entire row by 4. So that's what I'm going to do. I'm going to take 1/4, divide it through, or take 4, divide it through, or multiply by 1/4 that entire row. Okay, so I'm writing a new matrix. I'm identifying the thing that is not changing first. The thing that is not changing is the first row. I'm not changing the first row. The second row, I'm going to multiply through by 4. That gives me 0, 1, Go figure. That was the point, right? That had better come out to be a 1. Then 6 over 4. So we have 6 over 4 there, which reduces down to 3 over 2. So 3 over 2. Okay. Now, we're almost there. I'm kind of thinking about my goal here. And it's like, this is almost exactly what I want. The only problem is we need a 0 there. And so I ask myself, how can I get a 0 there? Well, -1 plus, it happens to be 1, gives me 0, which is what I want. But actually, I'm going to make a little bit of room here. And so I'm going to say, all right. In other words, so if you'll notice, and this is the way we're going to do it with a 3x3 and a 4x4 and a 5x5. I won't give you a 5x5. You have a 4x4 coming up in your homework, but it ain't bad because this is what we're going to do. So if you'll notice, we got zeros under here, and we're just going to kind of work our way down until we get to the bottom. And then we're just going to get zeros up above it. That's the next goal, right? So I'm going to say, all right, in this case, it's easy because I ask myself, what number do I need to add to -1 to give me a 0? Well, that number is 1. Then I look right here and say, well, what times 1 equals 1? Oh, it's 1. We're good. We don't need to worry about it. So I'm just going to multiply this guy by 1. I mean, I don't even need to write that there. We're just going to add that row to that row. But I kind of wanted to go through the reasoning because if that's in another example, you'll see when it's not 1, we kind of have to do the same thing we did here and say, well, I need to add that to that. And so it needs to be a -3. So I need to multiply everybody through by -3. In this case, it happens to be a 1. And so whatever. Okay, so now let's write down the matrix. The row that is not changing is the row in the bottom. Now that we're working our way back up, I'm going to say we are not changing this row. So I'm going to write him down first. 0, 1, 3/2. Now, I take that row and add it to the row above. The 0, and this is the nice thing about this, you could pretty much forget about this column because, well, 0 times anything is still 0. Add it to 1, it just stays 1. Nice. 1 plus -1, or we could think about it up here. 1 plus -1 gives me a 0. And then we have 3/2 plus -1, 3/2 minus 1, but 1 is 2/2, which is 1/2. And so when I add those together, I get positive 1/2. Now, finally, what I'm going to ask you to do is in your homework, when you get to here, finally just write, oh, this means that x equals 1/2 and that 0y equals 3/2. Put a box around it, and that is your final answer right there. It makes sense how we did this. Is that a north-south?
I think so.
Okay.
Yeah.
Okay. So, and at first it's a little weird, and I get that. That's why we're going to do a few examples here. So this is the same exact thing that we did right here. This is the exact same thing that we did. The only difference is we're not writing x's, y's, and equals every time. And you can see like this, like just by this kind of reasoning that we used here and that we used last time, Wednesday, like it's all captured right here. It's the same stuff. But now we're kind of thinking, it's almost like we're playing a game. It's almost like Sudoku. I think about this a lot like Sudoku. Have you ever played Sudoku? No, it's a number game. You have like a grid and you're trying to put numbers in certain orders and stuff like that. But like, what's nice about this is we could completely abstract from the problem at hand. We don't have to be thinking, well, this is a line and where does it cross here and there? Where does it? This is just the game where we're given a thing like this. We have rules of multiplication and addition of stuff, and we're trying to turn it into this thing right here. Now, well, in the next example, am I good to erase this?
Yes.
Okay. In the next example, we're going to get to a point, and you might say, wait, why don't we just do this? And I want to show you why we're not going to do that. Okay, so here is the example I want to do. It is from the book. It's on page, I think our page numbering is the same. It's page 178 for me, but this is the chapter 4, section 4 exercises, problem number 6. So this is chapter 4, section 4, problem number 6. And it gives you this system of equations, and it says to solve the system. The system it gives us is 6x minus 4y plus 5z equals 31. 5x plus 2y plus 2z. And x plus y plus z equals 2. Now, one thing I want to address is that, does the order matter at all? Which equation you call first, which one you call second, and which one you call third?
No.
No, right? Because like, let's think back to the 2x2 case, right? You have 2 lines. One of them goes this way, one of them goes this way. Does it matter which one you write first? No, they're the same 2 lines, right? In the same way, these are the exact same equations, and we could do them in any order we want. And this is going to be a principle that we could use at any time when you're doing your matrices. If you see like, you know what, it would make more sense to just flip these 2 rows at this time. Go ahead and do it. You could do that at any time. You could interchange 2 rows at any point along your calculations. Since that's the case, instead of writing this as 6 minus 4, 5, 31, 5, 2, 2, 13, 1, 1, 1, 2, I know that my goal is to get the second step is to get a leading one, to have a 1 in the first place. So I'm thinking, well, this last one already has a 1. So I'm just going to go ahead and write it like that to begin with. I'm going to say, well, if the place I'm trying to get to, in fact, I want to give myself a little bit of room. If the place I'm trying to get to has a 1 right there, and I have one that starts with a 1, well, let's just go ahead and make that my first one. I might as well. So this row will be 1, 1, 1, 2. So 1, 1, 1, 2. The next row, again, I could take either one. And when I did this earlier, I just wrote them backwards for no reason. Like it won't make much of a difference. But I just went ahead and said, okay, we'll make this one the second row. So we have a 5, 2, 2, 13. 5, 2, 2, 13. And then the last one will be 6 minus 4, 5, 31. 6 minus 4, 5, 30. Now, thinking about my goal, what I'm trying to get, what I want out of this, again, is I want x by itself, I want y by itself, and I want z by itself. So in the end, this is what I want this. I want a 1, 0, 0, some number, 0, 1, 0, some number, 0, 0, 1, some other number. That is my goal. And so the first thing I'm going to do is kill these 2 numbers. In other words, I have a leading 1. Check, we're good to go. If I didn't have a leading 1, like if this were 2, 2, 2, 4, I could say, well, if I divide this guy by whatever number's in front, then I will have a leading 1. That's how you would do this. So I have a leading one. We're good to go. Now I just need to turn that into a 0 and turn that into a 0. Now, the way I like to do this, I like to do this in kind of one step. I'm actually going to take 2 steps, but I'm going to think about it like this. Okay, my goal at this point is to get zeros right here. I know the thing, and this is going to be in general, this is how you're going to do this. You're going to say, at this point, when I'm getting zeros beneath this guy, I am not changing the first row. So I'm not changing the first row. I'm going to copy him down without really thinking about it. That's going to be what I'm going to do. But now I need to kill that 5. So the only way to kill that 5 is if I had a -5. And so I'm going to think, okay, I need a -5. But now I don't really need to use my brain as to what number I need to multiply this by, right? Because I want -5 times this equation, and I'm going to add it to that equation to kill off that 5. And so if that needs to be a -5, that means I need to take that first row and multiply him all the way across by -5. I do that. I get a -5 times 1 is -5. -5 times 1 is -5. -5 times 1 is -5. -5 times 2 is -10. Okay. So now, when I add -5 times the first row to the second row, what I get is -5 plus 5 is 0. Go figure. That was the whole point. That's why I figured out -5 needs to be the number. -5 plus 2 gives me a -3. So here I have a -3. -5 plus 2 is another -3. -10 plus 13 is now a +3. Okay. Now, we could have written, and you can see like what I did here, right, is I took -5 times that equation and added it to this equation. I'm just being lazy. I'm not writing all the X's and the Y's and the Z's and stuff like that. Can you see that that's what we did?
Yes.
Okay. I'm going to do the same thing with the bottom equation. And I'm going to say, okay, I need to multiply this equation by some number, and it needs to give me a -6 right here. So I say, well, I'm going to have to multiply that guy across by -6. That's the great thing about having a leading one. You don't really have to use your brain for that. It's like, well, you have a 6. You need to add it to a -6. So I'm just going to multiply the whole thing across by -6. -6 times 1 is -6. -6 times 1 is -6. -6 times 1 is -6. -6 times 2 is -12. Now I'm going to take that and add that to the bottom equation and put him in the bottom place. So we have a -6 plus a 6 is a big fat 0, just like what we wanted. -6 minus 4 is a -10. -6 plus 5 is a -1. -12 and 31, it should be a 19. 19, yes, 19. Positive 19. Okay, so that's pretty much, that's like, you can think about that as like step 3. We put our step 1, we put everything into a matrix. Step 2, we got a leading one. Then we just multiplied that top equation by whatever numbers are going to kill the 5 and the 6. I did that twice. In the first case, it gave me this, which I added to that to give me that. In the second case, I multiplied this by -6. It gave me that. I added it to the bottom, and it gave me that guy right there. Okay. Now, if you'll notice, this thing right here, it's kind of like a 2 by 2. right? From if we forget that this column exists and we forget that this row exists, it's kind of like we were given a 2x2 system to solve. And indeed, yeah, we kind of forget about all of this right here because it's just zeros. So now we're going to start back over at the top. We have a system written in matrix form. So step 2 is get a leading 1 right there. In that case, that top left part of it needs to have a leading 1. -3 divided by what equals +1?
3.
-3. -3, right? So I need to divide this guy by -3. So that's going to be my next step. In order to get a leading 1, I need to divide that entire thing by -3. And so 1, 1, 1, 2. The first thing I do is I'm writing down the row that is not changing. So I did that. And I know I'm not changing the bottom row with this step. So I'm just going to copy down the bottom row. Exactly. Now what's changing is I'm multiplying this guy through by -3. 0 stays a 0. -3 divided by -3 gives me a +1. That's what we wanted. That's the whole reason we were doing that. Now -3 and -3 is again a +1. +3 divided by -3 gives me a -1. Okay. Now I need now the goal, we're playing the same game now. It's as though, right, now we just have, if we were only given this 2x2 system, or 2x3, then I would want zeros beneath this guy. And I could see, yeah, that jives with my goal, right? I have a 1 here, I have a 1 here where I want it. Now I need a 0 down here. So that's what I'm going to do. What number plus -10 gives me a 0?
10.
+10. So I know, okay, I need to turn that 1 into a +10. Well, there's only one way to do that. I need to multiply that guy by 10. I'm going to multiply that entire equation through by 10. So we get a 10 times 1 is 10. 10 times 1 is 10. 10 times -1 is -10. Now I'm going to add that to that row. So I'm going to rewrite this. I guess I'll do it right here. First thing I'm going to do is rewrite the rows that are not changing. The top row is not changing. 1, 1, 1, 2. The second row is not changing. So I have a 0, 1, 1, -1. The bottom row is changing. So let's go ahead and do that. 10 and -10 gives me a 0. Oh, and the 0 there, we don't need to worry about. We'll just put them right there. Okay. 10 and -1 gives me a +9. -10 and 19 gives me another +9. Okay. So if you remember, right, when we got down to this point in the last part, it was like a 4 and a 6. And I said, well, what that actually is, and you can see in this case, is we have a 9z. That's what this means. 9z equals 9. And so we would divide both sides by 9. We could think about this kind of abstractly and say, well, I need to turn this number into a 1 in order to get the thing that I want, right? And so we'll turn that into a 1 by dividing everybody by 9. So I'm going to go ahead and write this way. So I'm going to copy down my matrix one more time, right up here. The things that aren't changing are rows 1 and row 2. So 1, 1, 1, 2. 0, 1, 1, -1. 0, 0. Okay, so now this is the thing that's changing. Multiply through by 1/9, or in other words, divide by 9. And we get 0 divided by 9 stays 0. 0 divided by 9 stays 0. 9 divided by 9 gives me a 1, which is what I was looking for. 9 divided by 9 gives me another 1. Okay, now we're here. And I've been looking forward to doing this for a while now. At this point, I'm going to go ahead and erase the original system that we wrote down. I want some room for what I'm about to do. At this point, what we could do is say, wait a second, this thing that you have right here tells me that x plus y plus z equals 2. That's what this means, right? We could say, okay, if x plus y plus z equals 2, this means 1y plus 1z equals -1. So y plus z equals -1. And this says that z equals 1. So what we could do, if we were so inclined, and I'm going to say we don't do this, and I'll show you why. You will see why in just a minute. We're not going to do it this way. But what we could do, and the way that the book says to do it, is to do the following. It's like, we have one variable all by itself. We could plug that variable back in to the other two equations. So if we were to do that, if I were to say, well, if z equals 1, then I could plug in the 1 here, and I could plug in the 1 here. What would that give me? Well, let's see. X plus y plus 1 equals 2. This would give me y plus 1 equals -1. Now what I could do, I could say, well, let's just get these guys by themselves. In both cases, I would subtract off 1 from both sides. That would give me, okay, I'm just solving this equation for x and y. Getting x and y by itself gives me 2 minus 1 is a +1. Yeah. And then y plus 1, I take that over and get y equals -2. So I found that z equals 1. I found that y equals -2. And then finally, I would substitute that back into my original equation and say, well, we could take the y and plug him in right here. That would give me x plus -2 is the same thing as a -2 equals 1. Add 2 to both sides. And I get x equals +3, and I would have my answer. I would have x equals 3, y equals -2, z equals 1. What we're going to do is exactly the same thing. It's exactly the same thing, and you'll see that it is exactly the same thing, but we're just going to do it in a matrix. And we're going to think, well, kind of like how we had before. When we started off with a 1 right here, we could get zeros here pretty easy by just saying, well, multiply by negative that number and then add them. Multiply this guy by negative that number and then add them. We did the same thing here. We said, well, you have a 1 here, so multiply by negative that number, which turned out to be a +10, and then just add them. We can do the same thing working our way up now. So that's the idea. We start by getting zeros below, and now we're going to start over here and get zeros above. And this one turns out to be pretty easy, because in order to get a 0 here, I need a -1, which means that I need to multiply that whole thing by -1, giving me a 0, 0, -1, I shouldn't put it in parentheses because I keep doing that, 0, 0, -1, -1. Right, so what did I do? I took -1 times the bottom row, and it gave me this. Now I'm going to take that and add it to here. Let's see what that gives me. This time, I am not changing the bottom row, 0, 0, 1, 1. I am changing that row, but I'm not, at this point, changing the top, so I go 1, 1, 1, 2. I add that to that. 0 plus 0 is 0. 0 plus 1 is 1. -1 and 1 is a 0. -1 minus 1 is -2. Okay, same thing. Now I need a 0 up above, right? So I'm getting zeros above that guy. And I'm going to say, well, it's basically the same thing. If I multiply this guy by -1, I'll get a 0, a 0, a -1, and a -1. I'm going to go ahead and add him to the top now. So I'm going to need a new matrix. And I'm going to say, okay, now it's the bottom one is not changing. And the second one is not changing. And I can see that, yeah, look at it. That's my goal, right? I'm almost there. I have all of this right here. Okay, so that's nice. Now I need to kill that one. Give me a 0, which is what I'm doing here. 0 now plus a 1 is 1. 0 and a 1 is 1. -1 and 1 comes out to 0, which is what I wanted. -1 and 2 gives me a +1. Do these two things that we just did over here seem familiar? It's exactly what we did earlier, right? When we plugged in the z, we ended up subtracting off a 1 from here. That's how we got that guy. We subtracted off a 1. We subtracted off a 1 from here. That's how we got that guy right there. We're ultimately doing the same thing. We're just doing it in a matrix. Now, finally, we're almost there. So we're going back from the beginning. We had a leading one. We used that to get zeros right here. Then we moved over and got a leading one here and got zeros beneath it. We moved over to get a leading one here, or a trailing one, whatever. Now we have a 1 right there. Then we're going to use that one to get zeros above it. And we're just going to work our way back. Now we have a 1 right here, and we're going to get zeros above it. So in order to do that, the only thing I could add to that to give me a 0 is a -1, which means I need to multiply that entire equation by -1. So when I do that, I get 0, -1, 0. -1 times -2 is a +2. Okay, last step is actually do the add. So I'm not changing the bottom row. The second row is not changing. Now the top row, I'm taking -1 times that row, adding it there. I've already written the stuff right here, which looks nice. 0 and 1 is 1. -1 and 1 is 0. 0 and 0 is 0. 2 and 1 is 3. And look at that. X plus 0 equals 3. That's what we got. 0, y, 0. So y equals -2. That's what that is. 0, 0, z equals 1. And yes, z equals 1. So then we can finally write down x equals 3, y equals -2, z equals 1. This is how we deal with systems of equations. It's gonna get like the two examples that I did right now. Hey, buddy. The two examples I did right now don't involve fractions. You're gonna see fractions. It's gonna be rough. But do you have all of this written down? Or do you need a minute?
I got it.
Okay, so I'm going to write down these steps for you. So write system as augmented matrix. That's pretty straightforward. I think that, like, do you have any questions about that? Like how we do that? I think we went over it pretty well, right? Okay.
Yeah.
Right system is augmented matrix. Be careful that you've accounted for all the variables that the question has said. Usually it's pretty obvious. They have XYZ, XYZ, XYZ. Sometimes there's missing stuff, in which case you're going to need to make sure you put a 0 in for the missing stuff, that you keep everything in order. There are a couple questions in here where they like deliberately try to mess with you. So you think, oh, okay, the 2 goes here and the 1 goes here. But what they've actually done is reverse the order. So be careful with that. Write it as an augmented matrix. 2. So you have your augmented matrix. It has a bunch of stuff, and I'm just going to write it as like A, B, C, blah, 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 D, E, F, blah, 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 G, H, I, blah, 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 blah. Step 2, get a leading one. Get a leading one. And the very first time you do this, it's going to be the very top left. In this case, it's A, right? And so I would think, well, if that's an A and I need to turn it into a 1, I need to divide that row by an A, right? So in other words, what I'm saying is, in this case, divide row 1 by A. So if we were given something like this, I would say, okay, C, blah, 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 D, E, F, blah, 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 G, H, I, blah, 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 blah. We go 1 divided by A times that entire top row. And that's going to give me, well, A over A is a 1. That's the point. Get a leading one. Then you have whatever B over A is, C over A, blah, 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 blah. And then all these guys are just whatever they were to begin with. Okay. Now, step 3. Get a column of zeros beneath your leading one. Under your leading one. And this is why we put a 1 there in the first place, is because now it's pretty easy. Like, I'm going to add this row to this row, and I need to kill that D. So in order to turn, I need to make that 1 a negative D. What do? Well, I multiply row 1 by negative D to give what it's going to be ugly, but it'll be negative D. And then, well, I guess, don't think about this as a formula. I'm just kind of showing you what it's going to look like. It's going to give you that, right? Something like this, that leading row. And what I like to do is write it somewhere on the outside of the matrix. Your paper is going to look ugly, and that's what I expect. Like, let me show you what I mean. Like, when I was doing these, right, I have a bunch of just ugly stuff everywhere. I've written stuff above and below. Where are they? Well, that one turned out to be easy. You can see, right? Like, I write stuff above and below it. I have little scratch marks everywhere when you have rational numbers. It's going to be ugly, and that's cool. That's fine. Just, it should look ugly. That's what I expect, that it's going to look really ugly. You're going to have stuff everywhere. And so what I'm saying here is, like we did before, I'll post this as soon as I can. It takes forever to upload it to YouTube, but you could go back and watch this stuff. But what did we do? Well, we multiplied that row by the thing that's going to kill this row. And then what I did is I just wrote it on the outside, right? We still had this. I'm not changing the top row. Like, this is right here. I would just write it above there. And then with the other one, I'm going to row multiply and again multiply row 1 by, in this case, I need to kill that G because my whole idea is to get a bunch of zeros under here. I'm going to multiply row 1 by negative G to give, well, I'm going to write it down here and say, well, negative 1, I'm sorry, 1 times negative G is negative G. Just keep multiplying it through. You would get whatever a negative G B over A is, negative G times C over A, and so on. And then we just add them, right? So then we take that, add him to there, add him to there. And that's going to give us big fat 1, B over A, C over A, and so on. This guy is going to be a 0 and something here, something here. That guy is going to be a 0 with something here, and so on. Okay, so that's like step 3. We clear zeros beneath there. Then you'll notice is now it's as though you have a brand new system. And so then once you're down to here, you just go back to step 2. That is, you turn this guy now into a leading 1. So whatever number that happens to be, I'm just going to go ahead and write it like this. Going back to step 2, let's say we had a big A and a B and a C and a D and an E and an F. We'd say, well, step 2 says I need to get that guy into a number 1. So I need to divide by whatever number that is. I'm going to divide the whole thing by 1 over A. And so when I do that, that's going to give me a 1, B over A, C over A. We have D, F, and so on and so forth. And then we're just going to continue on, right? And so then it's back then step 3. Get a column of zeros under your leading 1. Well, I need to multiply this by negative D in order to add them together to get a 0 here. So multiply by negative D. That gives me, I'll just write it down here, negative D, negative DB over A, negative D times C over A. Then I'm just going to add these guys together to get zeros and so on and so forth, right? Like I drew this like looks like a 3 by 3, but it could have been any size. And you can see like all we're going to do is once we get a column of zeros, we're just going to pretend then we have a new system and you're just doing the same thing over and over. Does that make sense?
Yes.
Okay. So once you do that, you're finally, once you are down to the bottom, so 4. Once you have this picture, a 1 and a 1 and a 1 and a 1 all the way down, right? And this is, I don't know, D, C, B. And then you have a bunch of things here. This is called upper triangular because, hey, look, it's like a triangle in the upper part, right? Once you have this, now you're playing the exact same game you played, but you're going to start here and kill off those columns there. So once you have this, get a column of zeros above the last one. And we did that in class, right? And it's pretty much the same thing. The great thing about having a 1 there, and that's like what we did in the very first example. Once we had 4y equals 6, we said, well, let's get y by itself. In other words, you're getting the final variable is equal to something. We could go through and plug them in, but it's exactly the same thing as just saying, well, whatever number this is, let's give that a number. Let's say it's like, let's call it little a. To get that guy to go away, and this is a nice thing, is that you know that all of these are zeros too, right? So really, all we're doing is just looking at those two numbers, and we're saying, well, if that's an a, this thing needs to be a negative a, so we're going to have a negative a, and then whatever negative a times that guy is, negative a times big D, and then we just add to that row, and it turns that into a 0, turns that into whatever it is. We do the same thing for each one of these. If that were a little b, we would say, well, multiply this guy by negative b, and we have negative b times d. Add that to that guy to turn that into a 0. Then the final one, I don't know, let's call it a c. We would say, okay, I need to multiply that by a negative, whatever number that is, I guess a negative c times negative c times d. Add that to that guy, and that will give me my column of zeros above the last one. Then guess what? Now, just like we said before, right? Once that becomes, I'll actually write it out. This will give us something that looks like this. 1, 0, 0, 0, 0. Oops. Some number 1, 0, 0. Some number 1, 0. 1, 0, 0, 0. And then some numbers here. We're basically, it's kind of like we're just turning this problem upside down, right? So the first case, we turned that into a 1 and got zeros beneath it, like that. And then we said, oh, this is kind of like a new problem, and we could use the same method to get rid of that. Well, this is what we're doing here. Now, we started here and got zeros above that guy, and now we could say, well, this is kind of like same thing. This is kind of as though we were in that situation. And so we could say now, starting here, we already have our leading one or our trailing one. We could say use this then to get zeros above the last column. And so, in other words, repeat step 4. So that you get zeros above there. Move back 1 and repeat so you get zeros above there. The really nice thing you'll notice as you start doing this is that once you've cleared stuff out, right, like all of these guys are zeros, then when you go to add these back in, you're only working with those two numbers right there. After you've done that, all those are zeros. So this guy is just one, there's just that number there and that number there. You're still just working with two numbers as you're moving those guys back. Then once that has zeros above it, now you're just working with those two numbers and stuff like that. Actually becomes really easy. Like once you get down to this point, it gets pretty easy.